Hi, this presentation is for assignment 2 practical data mining project, and the topic is investigation into the leave rate of employees, and is prepared by Yidi Xiang, Wang, and Jiageng Liu. The dataset we have is about a 11 years old tech company, which is successful throughout the years, but they have increasingly more employees have left the company in the recent years. So the problem we're trying to solve by the management of this company is keep important employees who could potentially leave the company. And that comes down to the data mining problem, which is use this dataset to make predictions of which employees have tendency to leave the company and use that to try to keep the important employees. Let's take a look at the attributes of this dataset. Satisfaction level, which is float, means the satisfaction level the employee gave to the company. Last evaluation means the last time a employee was evaluated and a score the company gave to this employee. Number project means the number of project employee has done in the company. Average monthly hours means the average hours a employee spent working in this company. Time spent company is measured by year, means how many years a employee have worked at the company. Work accident is a boolean. Zero means employee haven't had a accident in the company, and one means they have. Left is the one that we're targeting. Left means whether the employee have left the company or not. Promotion last 5 years means whether a employee have been promoted in the last 5 years. Sales, which should be labeled position, but somehow was labeled sales in this data set, means various positions in this company. Salary have three levels, which means the three different levels, low, medium, high, of an employee's possible salary. We have done a explanatory analysis on the dataset, and from this violin plot, we can see that the employees with zero point 0.5 to zero point 0.8 satisfaction level is very likely to stay. But the employees with satisfaction level around zero point 0.4 is more likely to leave than the ones with satisfaction level around zero point 0.8. From the two bar charts on the left side, we can see that the employees with two projects done in the company have much higher leave rate than the ones with three projects. This could possibly mean that something happened when the employee is trying to do the third project in this company, maybe a filtering process. Employees with seven projects done in the company is 100% kept inside the company. None of them left. Maybe they become management level, uh, managers, or they're very important to the corporation. Here is a scatter plot constructed using loss evaluation as x-axis, average monthly hours as y-axis. Red means employee have left the company, and green means they have not. This scatter plot reveals two problems when you look at it. Many capable employees have excessive work pressure, so a lot of employees with very high evaluation scores, which means they are very capable, have too much working hours in the company. And second problem is that a lot of employees with low performance have left. You can see it by looking at the left and downside corner of the scatter plot. A chi-square test for association is conducted, and we found out that the categorical variables such as number project, time spent company have association with the left variable, which means that this relationship is worth investigating into. And we have also done a t-test for difference in means, and we found that all the quantitative variables like satisfaction level and loss evaluation have no association of the left variable.
In the preprocessing step, we separate the features into category columns and quantity columns. As we can see, the category column include number project, time spent company, work accident, promotion last 5 years, sales, and salary, which are the category columns. And our target variable is left, which means we use the category columns and quantity columns to predict the left variable. In the feature engineering process, we use binarization to separate categorical features into one-hot encoding. As for the quantitative features, we use binning uh, to separate these features into uh, each numerical bin, and then use binarization to separate them into each binary one-hot encoding. After we implement the preprocessing step, and we use different feature selection technique to reduce the dimension of the features, such as variance threshold and select k-best, and chi-square, as well as the select from model. We use extra tree classifier and the linear SVC. As we can see, the reduced dimension features has less columns than the original features. For example, the XVC selected feature has only 36 columns, and the reduced feature matrix can be seen on the right hand side. You can see the matrix, the shape of the matrix. In the model performances and evaluation step, we define some parameter for the grid search, which is trying to find the best parameter of the each models. And we create the logistic regression, decision tree classifier, and random forest classifier to compare the performances of the model. As we can see, the logistic regression model with original features acquire the highest AUC score, which was 0.98%, and with 0.95 F1 score, and it only takes 1.69 seconds. As for other decision tree and random forest, it performs well, but it's not better than logistic regression. So we use logistic regression as our final model. The last model performance and evaluation step, we can see we create the AUC and F1 score table and uh, use the order of the AUC. We can see the logistic regression with the original feature is the best model. And so we check the coefficient of the logistic regression, and you can see that the satisfaction level between 0.09 to 0.1 has the highest coefficient, which means it contributes the highest effect to the target variable left, which means if the employee have satisfaction level between 0.909 to 0.1 are more likely to left, whilst those employee with high salary, which has a lower coefficient like negative 1.076, which means this employee are less likely to left.
So what we've learned throughout the projects are many things, including data processing, data pre-processing procedures, statistical methods to observe dataset and discover interesting associations, and how different data analytic models work, which is the most important one. Next time, if we have the chance to do this kind of data mining project again, we will try to build model baseline and see how we improve model performance by optimizing feature engineering and pre-processing processes. There are many things that we have done are not perfected this time. We will try to learn the knowledge about these feature engineering or pre-processing processes and how different model works. And I think we can do a much better work next time if there's a chance.